Hi there, you are welcome to another topic. And for today's topic, we'll be looking at the number and numeration. And before I continue, I remain the same person. My name is Abimbola Temitope. So looking at the concept of number and numeration, and I know you are familiar with this particular topic, being a topic you've been treated even since when you were in primary school, secondary school, and so on and so forth. So it's a common topic that everybody understands. But most people, most students always make mistakes when giving a question under this particular topic. They always make mistakes. Why? Because they don't understand the rules that govern this particular topic. The topic is called number and numeration. Today, I'm going to give you some rules that govern this particular topic. So, looking at the number and numeration, there's something we call fractions under it. And what is a fraction? What do we understand by fraction? A fraction is a part of a whole. A fraction is a part of a whole. When we talk about a whole, it means a what? It means we are talking about a whole thing, something that is full. Now, if I divide this particular thing into two now, it's no more a whole. That means I've divided it into half. Dividing it into half, that means that I have 1 all over 2, because it's two places. I have 1 all over 2. So given this, I have 1 all over 2 plus 1 all over 2, giving me 1. And this is 1. This is a whole. The 1 all over 2 and the 1 all over 2 is a what? Is part of a whole. This is a part of a whole. This is also another part of a whole. So the two parts of a whole joined it together to give me a whole number. Now, aside from that, what about if we have an orange like this, and we divided the orange into 4? You're asked to divide the orange into 4. That means between you and your siblings. So this is 4. That means we have 1 all over 4, 1 all over 4, 1 all over 4, 1 all over 4. Giving you 1 all over 4 plus 1 all over 4 plus 1 all over 4 plus 1 all over 4 is going to give me 1. Now, a part of a whole like this, a part of a whole is called fraction. Is called fraction. And when we talk about fraction, fraction has both numerator and denominator. It has both numerator and denominator. Remember, numerator and denominator. And when we talk about numerator, another name for numerator is called dividend. You can see it on the board. We have dividend. Another name for denominator is called divisor. And I want you to know something, that the numerators are always written at the upper level, while the denominators are always written at the lower level. As this case may be, A all over B, this is numerator, while this one is denominator. And another name for numerator is called dividend, while another name for denominator is called divisor. Now, we'll be looking at the types of fractions that we have. Types of fractions that we have. Let's look at the types that we have. Types of fractions. Types of fractions. We have 3 types of fractions. Number 1, we have what we call proper fractions. Proper fractions. And when we talk about proper fractions has a value. It has a value less than 1. It has a value less than 1. Remember, it has a value less than 1. Though it's a fraction, but once you divide it, the value that is going to give you, the result that will be given, will be less than 1. Now, and in proper fraction, the numerator is less than the denominator. The numerator, look at this, numerator is less than the denominator. For example now, look at this. If I write example, if I write 1 all over 2, which one is numerator? 1, correct. 1 is the numerator, while 2 is the denominator. As the case may be, look at it. The 1 is less than what? The 2. That means the denominator is greater than what? The numerator. And if you divide this, you are going to see it's going to be, this is what? This is 1 all over 2, giving me is 0.5. Giving me is 0.5. That is 0.5. Looking at it, you can see it's less than what? 1. Now, we have another one, 3 all over 7. You can see that the numerator is less than the denominator. And if you divide this, you are going to see that the number is less than 1. Another example, 3 all over 8. Another one, 5 all over 7, etc. Once you see that the numerator is less than the denominator, we call it proper what? Proper fraction. I believe you understand. Now, number 2 type of fraction, we call it improper fraction. Improper fractions. And what do we call improper fraction? Improper fractions are the one, improper fraction have a value greater than 1. You can see proper is what? Less than 1. So improper has value less than, greater than 1. Sorry. So improper fractions are fractions that have a value greater than 1. The value must be greater than 1. That is what we call improper. And looking at the word improper, you know, in English, we have, when we say improper, this is a prefix. It means not. For example, impossible. It means not possible. It means not possible. So improper means not proper. Something that is not proper. You cannot tell a child of 5 years to carry his father of 40 years. It is not proper. That means we have something like this, 40 all over 5. It is not proper. You can see, as the case may be. Now, that means that the denominator, listen, the numerator is greater than the what? The denominator. Example. Now, if you have numerator is greater than denominator, take note of that. If you have 7 all over 3, you can see 7 all over 3. This is the numerator, while 3 is the denominator. I believe you are following me. And you can see that this numerator is greater than 3. If you divide this, you are going to see that it's going to give us a mixed fraction, which is the third types of fraction. Now, another example, we have what? We have 8 all over 5. You can see that means we are turning the proper fraction upside down. Do you understand me? Now, another one, we have 3 all over 2. Another one, we have 9 all over 7, etc. That is the second types of what? Of improper fraction. And the third types of improper fraction is what we call mixed fraction. We call it mixed fractions. We call it mixed fractions. And when we are talking about mixed fraction simply means that a whole number, we have a whole number and a fraction written together. A whole number, take note of the point, a whole number and a fraction written together. So improper mixed fraction means a whole number and a fraction written together. E.g., if I have one whole number, 2 all over 3, you can see 1 is the whole number, 2 all over 3 is a fraction. So another one, we have 5 whole number. We have 2 all over 6. 5 is a whole number, while 2 all over 6 is a fraction. Another one, we have 3 whole number, 1 all over 2. 3 is a whole number, while 1 is a what? Is a 1 all over 2 is a fraction. I believe you are following me. And another thing I want you to take note is that the mixed fraction, we can turn it to improper fraction. And the improper fraction can what? Can be turned to what we call the mixed fraction. For example, let's do some examples under this. Examples. Example says, change. We have 3 all over 2 to mixed fraction. To mixed fraction. 3 all over 2 to mixed fraction. How do we change 3 all over 2 to mixed fraction? How do we change 3 all over 2 to mixed fraction? This is what we mean. We have 3 all over 2. We now give us, how many 2 can we see in 3? Okay, somebody say 1. So we have 1. So what do we have left here? We have 1. Can 2 go in 1? Impossible. Yes, correct. So what do we need to write? We put what? Point and add what? And add is 0. That is how you always write it if you want to do what? Decimal. But in this case, we don't need to do decimal here. Abi? Okay, like someone said, say you add point. No, we're not going to do like that. So what we say, how many 2 can we see in 3? We have 1. It remains what? It remains 1 out of the 3. So you now say 1 all over 2. So that means 2 in 3 is 1 whole number. What remains what? 1 all over 2. You can see that we turn this word, we turn this improper fraction into what? To mixed fractions. Let me give you another example. Another example. Another example. We have the question say change 5 whole number 2 all over 6 to improper fraction. To improper fraction. How do we change this to improper fraction? Look at it very well. We want to change this to improper fraction. How do we change it to improper fraction? What you are going to do is that you will multiply the denominator by the whole number. Then whatever you get, whatever the result that you get, you will add it or you sum it to the what? To the numerator. This is what I mean. We have, the question is 5 whole number 2 all over 6. This one will give us 6 times 5. Can you see? 6 times 5. That is going to give us what? 6 times 5 plus 2. 6 times 5 plus 2. 6 times 5 plus 2 all over. What is the denominator? 6. Oh yeah, multiply this. 6 times 5 is what? 30. 30 plus 2 is what? That is 32 all over 6. Do you understand? We have 6 times 5. Multiply your denominator by the what? Whole number. Whatever result that you get, you sum it up to the what? With the numerator. And you got 32 all over what? All over 6. That is what? That is how to convert from mixed to improper and from proper to what? To mixed. And now, let's quickly talk about some basic operations in what? Some basic operations under fractions. Remember, the topic is number and numeration. Number and numeration. So, basic operations on fractions. On fractions. Now, what are the basic operations? Basic operations are, you remember the basic operation. What do we have? Addition. Thank you. And what is a sign? Cross sign, like this. Subtraction. subtraction, that is like hyphen. We have what? Multiplication. Multiplication. The sign is like this. Can you see? And we have division. This is a sign. We have one dot at the upper level and one dot at the lower level. So let's quickly talk about addition and subtraction. Addition and subtraction under fractions. Now, let me give you an example. Rule number 1 says, once we have the what? The same, common denominators. Once we have common denominators, definitely we're going to write it down, just one out of the denominators, and then we sum up the what? The numerator. Like this. We have 1 all over 5 plus 2 all over 5. What is this, everybody? The denominators are common. So once we have common denominators, what we are going to do is that we what? You just pick one, write the same thing, write one out of the denominator because they are the same thing. Even if they have 100 the denominators here and they are common, so just write what? 1. Now, what do we need to do? You sum up the what? The numerator. So what do I mean? You just say 1 plus what? Plus 2. So what will it give us? It's going to give us 3 all over 5. Now, if we don't want to do this, this is a basic rule. If you don't want to do this, once you find the what? The LCM of 5 and 5, the LCM is 5. You are going to say, how many 5 can we see here? In 5 is 1. 1 times 1 is what? 1. Plus, how many 5 can we see in 5? 1. 1 times 2 is 2. But in order not to waste your time, once you find out that the what? They have common denominators, you just write the denominator down and what? And sum up the what? The numerator. I believe you are following me. That is that one for addition. What about for the subtraction? If we have, let's assume we have 3 all over 7 minus 1 all over 7. What are we going to do here? We have common what? Common denominator. So what are you going to do? You are going to what? Put down the what? The denominator down because it's common. And you will what? You will subtract by saying the numerator 3 minus 1. And the result is what? 2 all over 7. 2 all over 7. And looking at this is the same way. You can also say, how many 7 can we see here? Is 1. 1 times 3 is 3 minus, how many 7 can we see in 7? 1. 1 times 1 is 1. And when you subtract, you will get the same thing. What about we have both the addition and the subtraction all together? For example, if we have something like this, we have let's have 1 all over 5. 1 all over 5 plus we have 2 all over 5. Then we have minus 2 all over 5. So you can see we have the 2 together. We have 1 all over 5, 2 all over 5, minus 2 all over 5. Now, what are we going to do? We have common what? Common denominators. So you just write 1. Even if we have 100 denominators here, so far they are common, you just write 1. So what do we have here? 1 plus what? Plus 2 minus what? Minus 2. In which is going to give us 3 minus 2 all over 5. And the result is 3 minus 2 is what? 1 all over 5. And that is our result. 1 all over 5. Okay. Let's continue with our examples under this. Let's continue with examples. What about if you have examples of mixed fraction? Example number 4. Example number 4. The question says simplify 3 whole number 3 all over 4 plus 2 whole number 2 all over 3. If you could remember, we can change what? We can change our mixed fraction to what? To improper fraction, like we've done in the first concept. So what do we need to do? Let's turn this one. We can say 4 times 3, that will give us 12. Then 12 plus 3, that will give us what? 15 all over what? All over 4. Then plus 3 times 2, that will give us 6. Then 6 plus 2, that will give us 8 all over 3. So what do we get here? What we are going to do is that we'll find the LCM of 4 and 3. So far, the denominators are not the same. Take note, the denominators are not the same. What is the LCM of 4 and 3? Okay, somebody said 12. Correct. The LCM of 4 and 3 is 12. So what do? How many 4 can we see in 3? How many 4 can we see in 12? That is 3, Abby. So we now say 3 times 15. That is 3 times 15. Then plus, how many 3 can we see in 12? That is what? That is what? 4. 4 times what? 8. 3 times 15. 4 times 8. So what do we get? 15 times 3. So what do we get? We have 45. So this is 45 plus 4 times 8. That is 40. That is 40 all over what? All over 12. So if we add this together or you sum it up, what do we get? 45 plus 40. That is what? That is 85 all over what? All over 12. Then you divide this to the what? To the simplest level or to simplest form. So how do we divide this? Can 12 go in 85? How many 12 can we see in 85? Let's check it. 12 times 5. That will give us what? That is no, it's more than this. What about if we divide it? Can 3 go here? How many 3 can we see here? No, 3 cannot go in 85. 3 cannot go in 85. How many 12 can we see here? We have what? 4 times 3, 12 plus 3, that is 15. Yes. So, now, how many 12 can we see in 85? Okay, somebody says 6. 6 can go. So, 12 times 6, let's check it. 6 times this, that is 12. I mean 1, 72. Abi? So, once you add another 12, it's going to give us what? What is this? 84. And we are looking for this. So how many this can we see here? That is 7. 12 times 7. What do we get? That is 4. Remain 1. That is 7 plus 1. 84. That is 7. So what else do we have? What else do we have? What is left? We have 1 all over what? 1 all over 12. Let's check if our answer is correct. We have 4 times 3. That is 12 plus 3. That is 15 all over 4. 3 times 2, 6 plus 2, 8 all over 3. The LCM is 12. So how many 4 can we see in 12? That is 3. 3 times 15, that is 45. Plus 4 times 8, that is, no. And somebody said 40. No, there's a mistake here. There's a mistake here. 4 times 8 is not 40. That is 32. 45 plus 32 will give us what? 127. That is 45 plus 32, 7. 4 plus 3 is 7. So 77 over 12. This is correct. 77 over 12. Now, you have to be patient. If you are solving something under this form, you have to be patient. So what do we do now? How many 12 can we see in 77? Let's say 12 times 6. 12 times 6, 6 times 8 is 12. 2 remain 1. 6 times 1 is 6 plus 1, 72. That is 6 whole number. Out of 77, we have 72. What remains is 5 all over 12. If this one is confusing, you can also use another method, which is our basic method, the primary school method. What do? We say 3 all over 3 whole number 3 all over 4 plus 2 whole number 2 all over 3. What they are going to do is that they will add sum of the whole number together by saying 3 plus what? Plus 2. The whole number is 3 here. The whole number is 2 here. So 2. Then we find the LCM of this one. What is the LCM of 4 and 3? That is 12. How many 4 can we see in 12? That is 3. 3 times 3 is what? 9. Plus, how many 3 can we see in 4? That is in 12. That is 4. 4 times 2 is what? Is 8. 4 times 2 is 8. So what do we have? 3 plus 2 is what? 5. 9 plus 8 is what? Is 17 all over 12. Now remember, this is 5. How many 12 can we see in 17? 1. You add that 1. You know that 1 is going to be whole number. You add it, you say plus 1. This is 5 whole number. 12 in 17 is 1. What does it remain? What remains is what? Is 5. So 5 all over 12. Now we now have 5 plus 1 is what? 6 whole number. 5 all over 12. You can see we get the same thing. So if this one is confusing, you can use the other method. You can use the other method. Now, lastly, let me use do the joint one. Out of a case like this, the question says we should what? It says simplify 2 whole number 1 all over 2 plus 1 whole number 1 all over 4 minus 15 all over 8. Now turn this one to what? To improper fraction. 2 times 2, 4. 4 plus 1, that is what? 5 all over 2 plus 4 times 1, 4 plus 1, 5 all over 4 minus 15 all over 8. And looking at this, the LCM is what? Is 8. How many 2 can we see in 8, everybody? We have 4, correct. 4 times 5 is what? 20. Then plus 4 in 8 is what? 2. 2 times 5 is what? Is 10. Minus 8 in 8 is what? 1. 1 times 15 is what? Is 15. Then what do we have here now? You sum up this one. 20 plus 10 is what? 30. Then that means we have 30 minus, what is here? 15. 15 all over, what do we have here? 8. And the result is 30 minus 15 is what? 15 all over 8. And the result is, how many 8 can we see in 15? That is 1. What remains there? If you remove 8 from 15, what is left is 7 all over 8. And that is the other answer. Now, I'm going to write these 2 questions. Then when you solve it, you can drop your answer at the comment section. So these are the questions. Simplify the following. The following. We have the first one. We have 11 all over 14 minus 9 over 21 minus 4 over 21. Then the second question, 1 whole number 3 all over 4 plus 1 whole number 5 all over 8 minus 2 whole number 1 all over 3. So once you solve these 2 questions, you drop your answer at the comment section. So We're going to call it a day here. And with this 3 point of mine, I believe I've convinced you. And you can see, I've convinced you. There's nothing hard in this. We have numerator and we have denominator. So I'm going to see you next time. So drop your answer at the comment section. Thank you very much. I remain the same person, Abimbola Tibitokwe. Thank you.